Good afternoon, Karthik. Good afternoon, all. Hello, students. In our last lecture, we discussed about current division. Okay, just I revise in introduction that current division, and we are going to simplify some numericals related to that current division. Okay, so suppose two resistances are in So suppose two resistances R1 and R2 are in parallel. Rp is the effective resistance of parallel combination. What is the formula for Rp? Parallel resistance is given by R1 into R2 upon R1 plus R2, and I is the total current due to that source of potential, and that potential is V. From this point, current is like this. I is equal to I1 plus I2. So I1 is current through R1 and I2 is current through R2. Okay. So what we write? I is equal to I1 plus I2. Now the formulas for current division are, means what is the value of I1 and I2? The given by current division. Current divides here from this node. Current divides as I1 and I2. So we are able to find out the values of I1 and I2 by using that current division. So what is the formula for that current division? Listen here. I1 is equal to what? R2 upon, how you write? I1 is equal to R2 upon R1 plus R2 into I. And what about I2? I2 is equal to R1 upon R1 plus R2 into I. Okay, these are the formulas for current division. Please join fast. How many of you are there? Sujit and Karthik is there. Other than them, how many of you are present? Shall I wait up to 2-3 minutes? Karthik and Sujit. Other than that, how many of you are there? Do you remember this? Do you attend our last lecture? Okay, Sai. Okay. Shall I continue? Are you ready, all of you? Okay. Okay. Now this one is a simple current division. Current divides from this point. That's why these are the formulas. Suppose whenever three resistances are in parallel, so at that time what we have to do in place of R2? Now we have to find out the current through R1, I1. At that time suppose another R3 is there. So we have to find out the parallel combination of R2 and R3, and that parallel combination of R2 and R3 is here, and here at the denominator R1 plus parallel combination of R2 and R3 and I as it is. This one is the formula for current division. In our last lecture we already find out that. Okay, so just I revise for these two resistances. The formula is for current division. Now we try to simplify one important exercise numerical, then we simplify one solved numerical, then we go to the forward equation. Today we have to complete all these points. So go on page number C in textbook exercise. Page number 37. Page number 37. Example 6. In a network shown in figure, calculate equivalent resistance of the network. Draw that diagram. All of you get this? Okay, page number 37. Okay, we are going to simplify this one. Okay, this one is our example 3 resistances. Suppose we name that resistances R1, R2 and R3. They are connected in parallel and 6 volt battery is connected across them. Okay. So first we have to find out the equivalent resistance of our network. So for your convenience you may consider the diagram like this जी अशी आहे horizontal. Consider that diagram vertical, then you clearly have idea that R1, R2, R3, these three resistances are in बॅकग्राऊंडला ना इकडे कन्स्ट्रक्शन वर्क चालू आहे बाहेर, तरी मी विंडो आणि डोर दोघे क्लोज केलंय. कन्स्ट्रक्शन साइट वरचा आवाज आहे. डिस्टर्ब होतोय का खूप? माझा आवाज येतोय ना? एम आय ऑडिबल? प्लीज रिप्लाय. ओके ओके संस्कृती, ठीक आहे. नाउ कॉन्सन्ट्रेट हिअर. दिवसभर आवाज येत असतो त्या कन्स्ट्रक्शन साईटचा. सम कटिंग काहीतरी करताय ते कंटिन्युअसली. ओके. बघा नाउ काय काढायचंय ते इन शॉर्ट मी दिलंय. Calculate equivalent resistance of the network. What is total R? Total R means these three resistances are in parallel and this resistance is in series. So in this way we have to calculate first overall resistance of this network. After that, what is the current I due to this 6 volt? V is equal to IR. At that time, initially we already calculate equivalent resistance. Insert that equivalent resistance in the equation V is equal to IR. Because you know V, you know R, equivalent resistance, then you are able to calculate I also. Now what about branch current I1, I2, I3? That we have to calculate by using current division formula just we studied. And just I repeat that equations for current division also. Okay. So now we are going to solve this one. You also try. माझं न बघता तुम्ही काढू शकता. Just I give you hint about the solution of this one. That first calculate the parallel resistance of these three. 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In this way find out the parallel resistance of this. Now after that what happen? This overall parallel resistance here, suppose consider a single resistance, that one is in series with this. So add this total parallel resistance plus 0.2 is your equivalent resistance of the overall network. Okay. Now once you calculate that equivalent resistance, then how to calculate R? V is equal to IR. Therefore, I is equal to V upon R, where V is equal to 6 and R means overall equivalent resistance you calculate here. Now branch currents I1, I2 and I3. To calculate I1, you have to take at numerator parallel combination of 6 and 3 upon 2 plus parallel combination of 6 and 3 into I. Okay. If you understand, then you try at your own. Otherwise, I am going to simplify with explanation. See here. Now equivalent resistance is equal to 0.2 plus R1 equivalent to R2 parallel to R2 parallel to R3. Means the circuit is like this. See here the circuit. Here parallel combination of R1, R2 and R3. So first we calculate RP1, 2, 3. For that do you understand this? We calculate the parallel combination of these three resistances. Suppose this is your R1, this is your R2, this is your R3. R1 equal to 2 ohm, R2 equal to 3 ohm, R3 is equal to 6 ohm. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. We simplify by LCM. 2, 3, 6. 6 is here. 2 3s are 6, 3 2s are 6, 6 1s are 6. So 3 here. 3 plus 2 plus 1. Okay, like that. Here the answer is 1. So parallel combination is 1. So what is the value of this resistance? 1 ohm. Now this 0.2 ohm and this parallel combinations overall resistance both are in series. So we have to add them to calculate the equivalent resistance. Suppose this is your equation number 1. From equation 1, R equivalent is equal to 0.2 plus 1. Therefore, R equivalent is equal to 1.2 ohm. Do you understand? All of you understand this? Or you have any difficulty? Please tell. Do you understand? All of you? Yes, Vipul. Okay. I is equal to 5. Right sign. Right answer. Very good. Okay. Equivalent resistance is 1.2. Means we simplify this one. We get the answer of this one. Now by using V is equal to IR. Now in V is equal to IR, which resistance we have to insert? Overall resistance of the network is 1.2. So write down these steps simultaneously. Write down all these steps. Write all these things and then this one. I am going to rub this. To find R, therefore V is equal to IR. Therefore, I is equal to V upon R equivalent. Now, just we calculate R equivalent, we know I because V is given quantity 6 upon 1.2, which is equal to 60 upon 12. Therefore, I equal to, is it visible? I equal to 5 ampere. 1/2. Let me check. Answers are also given. in your textbook. I1 is as a 2.5 ampere. The value of I1 is 2.5 ampere. Okay, I is equal to 5 ampere. Means second also we simplify. Everyone understand this? Why we consider R equivalent? Because overall potential applied across that network is V is equal to 6 volt. Therefore, we have to consider overall resistance of the network, that is the equivalent resistance. Just to calculate, it is equal to 1.2 ohm. Therefore, I is equal to 6 upon 1.2 and we get I is equal to 5 ampere. Means due to that 6 volt battery, current, overall current, maximum current is 5 ampere. So, write down this one also. Okay. Now after that, branch currents. How you calculate that? I1 is equal to, calculate I1 here. What you have to write? Rp23 upon R1 plus Rp23 multiply by I. Means the parallel combination of these two resistances is at numerator and at the denominator. This resistance plus parallel combination of these two. What is the formula for Rp23? Therefore, I1 is equal to R2 into R3 upon R2 plus R3 upon R1 plus R2 into R3 upon R2 plus R3 multiply by I. Okay. Does everyone understand this? Okay. 1/2 multiply by 5. Then you get right answer. 1/2 of 5 is nothing but 2.5. समजलं का सगळ्यांना? 3 रेजिस्टन्सेस पॅरलल मध्ये आहे. तर पहिल्या रेजिस्टन्स मधनं जाणारा करंट काढायचा असेल तर उरलेल्या 2 रेजिस्टन्सचं पॅरलल कॉम्बिनेशन कुठे येणार? न्यूमरेटरला. आणि डिनॉमिनेटरला कसली ॲडिशन येणार? तो रेजिस्टन्स स्वतः प्लस उरलेल्या 2 रेजिस्टन्सचं पॅरलल कॉम्बिनेशन. सो हियर पॅरलल कॉम्बिनेशनचा फॉर्म्युला काय आहे? R2 into R3 upon R2 plus R3. Now insert the values. You know your R2 is equal to 3 ohm. Here you write down the values. Here R1 is equal to 2 ohm. R2 is equal to 3 ohm and R3 is equal to 6 ohm. So therefore I1 is equal to R2 into R3. Means 3 into 6 upon 3 plus 6 upon R1 is what? 2 plus 3 into 6 upon 3 plus 6 multiply by I. I is equal to 5. So I1 is equal to 18 upon 9. 18 upon 9 upon 2 plus 18 upon 9 multiply by 5. Right? 5 upon 3 means yes, right. Okay, here 2 upon 2 plus 2 multiply 5. Therefore, I1 is equal to 10 by 4, 2.5 ampere. So, how you get I1? I1 is equal to, how many of you got this answer correct? Do you understand? All of you? Only our concept is up to this. To implement that current division. Above that only mathematical calculations. Right? You have to understand that mathematical calculations. Okay? Do you understand? बोलत नाही आज कोणीच काही? Listen. Five by 6. Okay, 5 by 6 and 5 by 3. Yes, yes. Answer is 1.66 and 0.833. Now therefore, write down I1, what do you get? 2.5 ampere. Write each and every step. Write all these steps. And everyone understand this Sanskriti? Do you understand? Vipul, yes. Okay. Okay. आज खूप कमी लोकांनी जॉईन केलंय. डू यू हॅव एनी प्रॉब्लेम? Why attendance is poor? Okay. Now calculate I2 by using similar formula. Therefore, I2 is equal to, we want to calculate I2. So we have to consider the parallel combination of R1 and R3 at numerator RP13. Here R2 plus RP13 multiply I. So I2 is equal to R1 into R3 upon R1 plus R3. That is the value of RP13. R1 into R3 upon R1 plus R3. Therefore R1 plus R1 into R3 upon R1 plus R3 and multiply by I as it is. Therefore I2 is equal to, what is the value of R1? 2 ohm, and this one is 6 ohm. Therefore 2 into 6 upon 2 plus 6 upon R1 is what? Sorry, not R1. Upon, we have to calculate I2, na? Here your R2. R2 is what? 3. 3 plus 2 into 6 upon 2 plus 6 multiply by I. Therefore, I2 is equal to 12 upon 8 upon 3 plus 12 upon 8 multiply by 5. Three by 2, or how you simply 3 by 2. 12 by 8 is what? 4 3s are 12, 4 2s are 8 upon 3 plus 3 by 2 multiply by 5. Therefore, I2 is equal to 9 by 2. 3 by 2 upon 9 by 2 multiply by 5. 2 2 cancel. Therefore, 15 upon 9, 5 by 3, which is equal to 1.66 ampere. 1.66 ampere. 3 1s are 3, 20. So, 1.66 ampere. Do you understand? Mathematical calculation आहेत हे सगळे. सगळ्यांना तुम्हाला याच्यापेक्षा कितीतरी कॉम्प्लिकेटेड मॅथमेटिकल कॅल्क्युलेशन यू एबल टू डू, राईट? So just hear our concept of current division. If you implement that formula properly, then you easily simplify this and you get I2 is equal to what? I2 is equal to 1.66 ampere. Write down all these steps. I2, yes, right, Karthik. I3 is equal to 0.833. Okay. So there is one simple trick to calculate I3. Anyone tell me that? In place of calculating like this, another way also you able to calculate I3. Tell me, anyone? How you calculate I3 other than this current division? Think over it. Anyone? Anyone? Yes, yes, Sahil. 5 equal to I1 plus I2 plus I3. Now current I from this point I is equal to I1 plus I2 plus I3. Yes, yes, Karthik. Right. Very good answer. मग एवढे सगळे कॅल्क्युलेशन I3 साठी करत बसण्यापेक्षा वी एबल टू कॅल्क्युलेट I3 लाईक दिस. डू यू कम्प्लीट ऑल दिस? रायटिंग केलं हे सगळं लिहून ठेवा नीट. ओके. Write down all these things. Now we are going to simplify for I3. Right? I is equal to I1 plus I2 plus I3. Therefore, I3 is equal to I minus in bracket I1 plus I2. Do you complete this board work? Shall I remove? If we consider 6, 6, again 6, then we get near about 3. Okay. Or to consider 1.66, if you remove the last 6, then it becomes 7. So when it becomes 7, you get near about 0.84. Approximate answer that I3 is equal to 0.84. Do you understand the logic of this numerical? By using the current division formulas, we try to find out I1, I2, I3. Overall resistance of the network, you have to find out. So you must recognize which resistances are in series and which are in parallel. Whenever both the ends are connected together, at that time they are in parallel. And whenever one end is connected and across the another end there is a battery source, at that time that resistances are in series. Do you understand all these things? Okay. Okay. Now we try to simplify another solved example but in different way. Go on your textbook page number. See page number 12. Problem 5. Do you get this? Page number 12. Problem 5. A current source of 1.5 milliampere with internal resistance of 3 kilo ohm is connected to the load. Okay, consisting of two parallel branches as shown in. See the diagram. Concentrate on diagram. Determine the current flowing through the 30 kilo ohm resistance. I am going to convert same diagram. Now this current R having source resistance, that is internal resistance Rs. Is is the current through them. Means I is current here, somewhat Is is there, and from this one is your I1, this is your I2 and this is your I3. This will follow the diagram. So here what is here, I think 10 kilo ohm. 10k, this is 30k, and what about Rs? 3 kilo ohm. 3 kilo ohm. Current through the source resistance they termed as I1. After I minus I1 is equal to I2. I2 is equal to I3 plus I4. Now they want to calculate the resistance, current I4. What they asked to calculate, I4 is equal to what? So in short, and I is given how many milliampere? Suppose 1.5 milliampere. I is equal to 1.5 milliampere is given. We know that I is equal to I1 plus I is equal to, now we start answering. Start simplifying. Do not confuse due to that source resistance. That simply termed as, that is one of the resistance of parallel combination. Consider that Rs, this R3 and R4. Rs, R3 and R4 are in parallel. And overall current through that parallel combination is I, and that I is equal to 1.5 into 10 raised to minus 3 ampere. 1.5 into 10 raised to minus 3 ampere, and 1.5 into 10 raised to minus 3 ampere is equal to I1 plus I3 plus I4. Okay, so 1.5 into 10 raised to minus 3 is equal to I1 plus I3 plus I4. Now first we calculate. First we have to find out that parallel combination overall current is given, V is equal to IR. I is given, therefore it is not necessary to find out equivalent resistance. First, how you calculate I3? I3 is equal to RP14 upon R3 plus RP14 multiplied by I. Do you understand? हा करंट काढायचा असेल तर ह्या दोन रेजिस्टन्सचं पॅरलल कॉम्बिनेशन इकडे येणार आणि डिनॉमिनेटरला दिस रेजिस्टन्स प्लस पॅरलल कॉम्बिनेशन ऑफ दिस वन मल्टिप्लाय बाय आय. डू यू अंडरस्टँड ऑल ऑफ यू? Okay, to calculate the current through this resistance, we have to calculate that parallel combination of these two upon R3 plus parallel combination of R1 and R4 into I. Okay, so how you calculate I3? 1 and 4, na? 3K and 30K. Shall I write in short? 3K into 30K R3 is what? 10K plus 3K into 30K. Try to simplify at your own also. What is I? 1.5 into 10 raised to minus 3. 3 3s are 9. 90 multiply 10 raised to 3 multiply 10 raised to 3. 10 raised to 6 is there. And here at the denominator 33 into 10 raised to 3. 33 into 10 raised to 3. Okay. So what is the value of that? 30 upon 11 multiply 10 raised to 3, which is equal to 10 raised to 3. So how I calculate I3? I3 is equal to 2.727 into 10 raised to 3 upon 10 into 10 raised to 3 upon plus 2.727 into 10 raised to 3 multiply 1.5 into 10 raised to minus 3. 10 raised to 3, 10 raised to 3 cancels. So I3 is equal to 2.727 multiply 1.5 upon 10 plus this one. 10 common काढू शकतो ना, don't cancel directly. Do you understand? If I take that common, इथला 10 raised to 3 आणि इथला 10 raised to 3 जर मी कॉमन घेतला तर हे काय होऊ शकता? वरच्या 10 raised to 3 बरोबर कॅन्सल. मग 10 plus 2 12.727 and multiply 10 raised to minus 3 as it is. Therefore I3 is equal to, how you simplify? By calci, na? The value of R3 I directly copy down, na? I have to calculate 2.73 multiply 1.5. Four point nine five upon 12.73 multiply 10 raised to minus 3. Okay, this is suppose near about 5 upon suppose 13, near about, approximate calculations, 0.4 milliampere. I3 is near about 0.4 milliampere. Okay. So how you calculate I4? Again calculate I4. Is there any simple trick? Point 4. I3 we calculate. Just remember I3 is equal to 0.4 milliampere now. And I is equal to I1 plus I2. You know I1. How you calculate I2? For that I1 कसा calculate करणार? I1 RP2324 RP24 upon R1 plus RP24 multiply by I. So I1, shall I simplify in mind? RP24 काय येणार बघा? 2 सॉरी याचं पॅरलल कॉम्बिनेशन कुठे येणार? वरती येणार. या दोघांचं पॅरलल कॉम्बिनेशन काय येणार? 10 into 30 kk ना? 10 raised to 3, 10 raised to 3, 10 raised to 6 upon 40 into 10 raised to 3. So 300 upon 40 into 10 raised to 3. So 30 upon 4. 30 upon 4. 7.5. 7.5. याची व्हॅल्यू येणार 7.5. Therefore I1 is equal to 7.5 upon R1 काय 3k plus 7.5k multiply I. So I1 equal to k कॉमन काढला की हा कॅन्सल होऊन जाणार 7 8 9 10.5 7.5 upon 10.5 multiply 1.5 into 10 raised to minus 3. Therefore I1 is equal to 15 upon 21 multiply 1.5 multiply 10 raised to minus 3. This is the value of I1. Means you calculate I1, you calculate I2. Okay. I3 you calculate, na? So I4 is equal to 5 I1 and I1 and I3. I1 is what? 1.07 plus I3 is 0.4 into 10 raised to minus 3. Therefore, 1.5 minus 0.4 and 1.07 somewhat. Yes, right. 0.7041.47 0.03 milliampere. Is it right? 0.03 milliampere. Somewhere we made mistake. This one actually the solved example in your textbook. Clear idea? Calculation आपल्याला mathematical multiplication division करायची orally सवय नाही राहिली ना. Okay. What is the logic? Do you understand logic behind this? This one is your I1. I2 is equal to I3 plus I4. So how they calculate I is equal to I1 plus I2? By using that you know I but you don't know I1 and I2. Okay. So they simplify for I2 directly, not necessary to calculate I1. And I2 is equal to this plus this, I3 plus I4. Okay. So not necessary to calculate I1. Means current division ज्यावेळी स्ट्रेट फॉरवर्ड व्हॅल्यू असेल, कॅल्क्युलेशन सिंपल असेल, त्यावेळी सरळ सरळ आन्सर येणार. लॉजिक तुम्हाला समजायला पाहिजे. फक्त करंट डिव्हिजन वेनेवर 3 रेजिस्टन्सेस पहिलं जसं होतं तसंच, पण पहिल्या ह्याच्यामध्ये व्हॅल्यू स्मॉल होत्या की नाही. इथे किलो ओहम रेजिस्टन्स दिले आणि मिली अँपियर करंट दिला. मीन्स 10 raised to minus 3 terms are there and 10 raised to plus 3 with each resistance. So the complications, so the calculations are slightly complicated. Okay, try to simplify on your own. Otherwise, I simplify in proper way on one page and then send it on our group. Okay, सगळ्या स्टेप्स इकडे सॉल्व करायला बोर्ड ही पुरत नाही आहे. Okay, so I am going to simplify on one single page by my own handwriting and then copy a photo of that. I am going to send on our group. Okay. Other than solution is other than your textbook, simple way. Okay, so after that we are going to study about the power, electric power, ability of doing work. You know, electric power is ability of doing work. And what are the units of power? Joule per second or watt. These are the units of electric power. Okay. Now we try to simplify and complete this part. Then in our next lecture we start some important network theorems. Okay, we try to complete this one today only. So don't leave the class. Stay live and listen here. So the unit of power is joule per second or watt. What is kilowatt hour? Kilowatt hour is equal to 10 raised to 3, or you may say 1000 watt hour. If you want to convert hour in seconds, so what is the equation? 1000 मल्टीप्लाय 1 आवरचे किती सेकंड होणार 3600 वॅट सेकंड्स. Therefore, how you 36 345. Okay, you may say that joules second also, or 3.6 into 10 raised to 6 megajoule. Okay, our electric power, electricity is calculated in kilowatt hour. How many wattage we use, that is in kilowatt hour. Another unit of power is horsepower. Electric motor horsepower, that what is horsepower, that 746 watt is equal to 1 HP horsepower. This is also one of the important unit. Okay, one is joule per second, one other one is watt. How you calculate kilowatt hour? किलो च्या जागेवर आपण 1000 घेतलं, वॅट hour च्या जागेवर आपण 3600 seconds घेतलं. Watt seconds is nothing but your joule, because joule per second is equal to watt. Therefore, joule is equal to watt second. In place of watt seconds, you may write joule, and this capital M for mega. 10 raised to 6 means mega. So 3.6 megajoule. Kilowatt, 1 kilowatt hour is equal to, is nothing but 3.6 into 10 raised to 6 megajoule. 746 watt is equal to 1 horsepower. Another equations for P is equal to VI. P is equal to I square R, means, and, or you may write down all these steps. P is equal to VI, P is equal to I square R, P is equal to V, means we want to skip now I. P upon R, no? V square upon R. These are the three important equations. If you know V and R, then we use the formula P is equal to VI. If you don't know V, and we know I and R, therefore we use the to calculate power, we use P is equal to I square R. And if you don't know current, then we use this formula P is equal to V square upon R. Now we are going to simplify one numerical of exercise related to that. Read carefully that and try to simplify. Again, page number 37. Page number 37, example 7. Page number, write down all these steps and write down this example. Those who are not having textbooks, write down this example on page number 36. This is the exercise example, that a power rating of soldering iron is 25 watt. Write down, power rating of soldering iron is 25 watt, full stop. If the resistance of another soldering iron, if the resistance of another soldering iron is half that of first, and its current is twice that of first, calculate the power rating of second soldering iron. Calculate the power rating of second soldering iron. Again I repeat. The power rating of soldering iron is 25 watt, full stop. If the resistance of another soldering iron is half that of first and its current is twice that of first, calculate the power rating of second soldering iron. Calculate the power rating of second soldering iron. There are two soldering iron. soldering iron are given. So here current is, so I1 R1, sorry, and here R2 I2. Power rating, here P1, here your P2. What is the first line? That power rating of the soldering iron is 25 watt. It is given 25 watt and you are asked to calculate P2. Write down page number 37 and exercise 7th. Exercise 7 numerical. This is given data. That is power rating of first soldering iron is 25 watt. Calculate the power rating of second iron, and what hint they given? That if the resistance of another soldering iron, means this R2, is half that of first, it is R1 upon 2. R1 is the resistance of first soldering iron and resistance of the second soldering iron is half that of first. What they say is again current is twice that of first. The current of that second soldering iron is 2 times the current of first one. Now how you calculate? Now you know that P1 is equal to, you know, I and R. I square, I1 square, R1. And P2 is equal to I2 square, R2. Right? You know P1. Therefore, write down I2 and R1 in terms of R1 and I1. So, what is the formula? In I2, how you write 2I1? 2I1 square. What about R2? R2 is R1 upon 2. So, here R2 is equal to 4I1 square multiplied by 2 upon R1, which is equal to, write down all these steps. Write down all these things as it is. Write in proper way, proper order up to this. Here we insert I2 is equal to what? 2I1. So we insert the value of I2 in terms of I1 and here we insert the value of R2 in terms of R1 because P2 is equal to I square upon R. Therefore I2 square upon R2. So insert the values. So what is the next step? I am going to write here. Here. After this step, we will continue here. P2 is equal to 4I1 square upon R1 multiplied by 2. So, is equal to 8I1 square upon R1. And what is the value of I1 square upon R1, which is equal to 25 watt? 4 by 2, Narka? 50 watt, right answer. I square R, I square R. For the formula क्या है? I square R. 50 watt is answer. Sorry. V square upon R. डोक्यात माझ्या. म्हणून P चा फॉर्म्युला काय असतो I1 स्क्वेअर R1. P2 चा काय येणार I2 स्क्वेअर R2. I2 in terms of I1 2I1 स्क्वेअर. I2 च्या जागेवर काय लिहिला 2I1. R2 च्या जागेवर काय लिहिला R1 upon 2. Now mathematically simplify 4I1 square into R1 upon 2. 2 to the 4 here remains 2. I1 square R1 and what is the value of I1 square R1? What is the value of I1 square R1? 25. So 2 multiply 25 the answer is 50 watt. Do you understand? Okay. Next very important point we are going to study in our next lecture tomorrow. Tomorrow at same time. Okay. Till then, bye. Do you have any question? Try to join all of you. Maximum. Must attend live lecture. And if you have any difficulty, please ask.